Hey guys, so I wanted to go over the quiz that we took today just to make sure that everybody was understanding what the answers are and what we were supposed to get out of this quiz. So these questions in the front are all questions that were on the practice AP exam for this year. So you'll notice that the wording that they use is very advanced. So please read your questions carefully to figure out what they're trying to ask you. Okay, so number one says, the table below gives characteristics of the rate of change of the function f on different intervals. Which of the following is true about f on their interval 3 is less than x is less than 4? Okay, so they're describing what's happening to the rate of change. So what is happening to the rate of change of the function? So not the graph itself, what's happening to the rate of change. They want us to look at the interval from 3 to 4. So the rest of this graph, yes, it gives you good information, but we don't really need it. We're only looking at the interval from 3 to 4, this right here. And it's telling us that the rate of change is positive and decreasing. So we know that another word for rate of change is slope. So what does it look like when something has positive slope? So that first word right there, positive. So positive slope would just be something that's going up generally. Something like that. That would be positive slope. Because we know that going this way is negative, and then flat is 0, and straight up and down is undefined. But positive is going up. So our graph, whatever it looks like, has to be going up. Another word for that is increasing. So looking at our answer choices, 2 of them say increasing. So that already cancels out 2 of my answer choices. Okay, then the other thing that it says is that it is decreasing. So not the graph. The graph is going up. We established that. But the rate of change of the graph is decreasing. So that means that it's concave down. So concave down looks something like that. And just notice as you go along it and you were to draw tangent lines. So here's a positive tangent line that's pretty steep. Then once you get here, still positive, but it's kind of less steep. It's more flat. Then right at the tippity top, it's a flat line, which we know is 0. Then over here would be negative lines, but they get steeper. But the point is that it starts as a positive number. We're not exactly sure what it is. Then it turns to 0. So positive number towards 0 means that it's going down, and then it eventually turns negative. So that means that our slope is going down. So that is concave down. So that has to be answer choice A. Okay, then question 2. Find the average rate of change of the function f of x equals x minus 2 squared plus 5 on the interval -1 to 2. So intervals are always x values. So anytime you see an interval, always, it is x values. So these 2 numbers here would be our x1 and our x2. So hopefully we remember our rate of change equation is you have to take the y values that go with those specific x's and plug them in. So if I'm using 2 and -1 here, so I'm going to have 2 minus -1 at the bottom, I need the y value at 2 minus the y value at -1. So I'm going to have to figure out what those 2 things equal. The way we do that is by plugging here. So I'm going to do this off to the side. If I want to find f of 2, I would plug in 2. So 2 minus 2 squared plus 5. Well, the inside here is 0. 0 squared is still 0, and then plus 5 is 5. And then if I want to find f of -1, we're going to substitute -1 for x. Okay, so now I have 1 minus 2, that's -3. Squared would make that 9, plus 5 is 14. So now I have 2 values to plug into these spots here. So now I really have 5 minus 14 over 2 plus 1. I'm going to go ahead and change this to a plus sign because that double negative. which gets me negative 9 over 3, which I'm running out of space, but would give me negative 3. So answer choice B. I did do this kind of the long way around. You could graph this and then type it in this way. Either way would work. Okay, third problem seemed to be the one that most people were struggling with. An object is moving in a straight line from a starting point. So honestly, it kind of gives a lot away just by that word. It's a straight line, so this has to be a linear function. The distance in meters from the starting point at the selected times in seconds is given in the table below. So there's our table. If the pattern is consistent, meaning like it's not going to change, which of the following statements about the rate of change of the rates of change of distance over time is true? So notice that they said it twice. Rate of change of the rates of change. That means that not only are we going to have to find the slope, we're going to have to find the rate of change between all the slopes. So what I'm going to do first is let's find all the delta x's. And it's not a trick. X is usually on top, y is on the bottom. It's just a sideways table. So for our delta x, between these two, it's plus 2. Between here, it is plus 3. From here, it is plus 5. Then on the bottom, if I want to find our delta y's, this is plus 8. Plus, that's 12. And then plus 20. Okay, so far all we found was our delta x and our delta y. But just a reminder, I'm going to write it here to the side. Rate of change is equal to delta y divided by delta x. Like that's the exact same formula that I used here. It's just different notation. So since I have my delta x's, I'll tell you what, I'm going to make myself like a list over here on the side. So rate of change. If I start with this first one, I'm going to do 8 divided by 2, which gives me 4. Then if I were to move on to the next one, 12 divided by 3, which also gives me 4. And then the last one, 20 divided by 5, also gives me 4. Now, this is what we expected to happen. They said straight line right here, so we knew that it was linear. So anytime we have a linear graph, the rate of change has to stay constant, but that is not what they're asking for. They're asking for the rate of change of the rates of change. So that means that we are going to have to do this again. ROC of ROC. Between these two, I mean, they're the same number, so really it's plus 0. And in between these two, also the same number, so it's plus 0. So the rate of change of the rates of change is constant at 0 meters per second. That is our answer. Now, it is a little bit confusing. The rate of change of the rates of change is constant at 4. I mean, if it had just said rate of change without this second part, that would have been true. The fact that it said it twice is what makes this not true. Then here they're trying to trick you by putting the word linear, but that only happens if these numbers were different. So the answer there is A. Okay, then on to the back. This is more of an open-ended question. Let h be a polynomial function. Selected values of h are shown in the table below where k is a constant. So see how there's a k? They're just letting you know that there's not going to be any variables. That's going to be a number. So part A, find the average rate of change of h over the interval -2 to 0. Intervals are always x's, so this would be x1 and x2. Show the work that leads to your answer. Okay, so let's start off with, let's find the y values that go with those x's. If x1 is -2, I would look at the table where x is -2. See that? So that means that this is the y value that goes with it. So actually, I'm going to label like this. This is x1 and this is y1. And then for x2, you find the x value of 0, which is right here. And we want the y value that goes with it. So this is going to be x2, y2. So now you just plug it into the slope formula. -1 minus 5 over 0 minus -2. So this becomes -6 over 2, which is just -3. So the rate of change on that interval is -3. Okay, then part B. Find the value of k such that the average rate of change of h over the interval -4, 2 equals 3. So they're telling you already that it equals 3, the rate of change. But if on that interval, you'll notice that something's missing. So this time, I'm going to call this x1 and x2. -4 is right here. So that's our x1, y1. And then 2 is right here. This is our x2 and y2. So if I were to actually set this up, like trying to find the rate of change between those 2 points, I would have k minus 15 over 2 minus -4. That's normally how you find rate of change. And then they tell us at the end it equals -3. So we're setting that equal to -3. Okay, so just the next step would be to simplify as much as you can. So at the bottom, that turns into a 6. Now from here, I'm going to multiply by 6 on both sides. That way it can cancel. And now I have k minus 15 equals -18. And we're trying to get that k by itself. So let's add 15 to both sides. K is equal to -3. So that was a coincidence that they're both -3. Okay, now the last part, part C. The graph of h is known to be concave up. So they're already telling you, heads up, it's concave up. Use the data in the table to explain and justify the reason for the concavity. So they're telling you, we know it's concave up, but now can you give me the reason that it's concave up? And I gave you the hint, find the rates of change over each interval. So looking at this table, I have 1, 2, 3, 4 intervals that I can look at. And I'm going to write them here. So I could do the interval -4 to -2. That would be the first 2 points. I could do the next 2 points, -2 to 0. Then I could do the next 2 points, 0 to 2. And then the last points I could do from 2 to 4. Okay, so let's find the rate of change on all of these intervals. So ROC. On that first interval, I would use these numbers here. So 5 minus 15 over -2 minus -4. That gives me -10 over 2, which is -5. Next interval, so now I'm using these two, the ones that are highlighted. Well, actually, I don't even need to do it. We already found it in the first step. So I know that the rate of change in that next one is -3. I'm going to write it out here so it stays in a line. Okay, now I want these next two. Remember that this k, we figured out that this is a -3. So -3 minus -1 over 2 minus 0. That gives me -2 over 2, which is -1. All of these are the rates of change. And then that last interval here, -1 minus -3 over 4 minus 2, which is 2 over 2, which is +1. So look at what's happening to those rates of change. -5, -3, -1, +1. So every single time, it's adding 2. So not only does that let me know that this is quadratic, because the rate of change of the rate of change. But it also lets me know that rate of change is increasing. See how we have to add to? And whenever rate of change is increasing, we know that that means concave up. Okay, so that little gray part, I tried to start off your sentence for you. That way you would know where you're going. So h of x is concave up on the interval -4 to 4 because the rates of change over equal length input intervals so notice that every one of these intervals is 2 apart, is increasing. And that's all you really need to write. Okay, cool. That was the quiz. Let me know if you have any questions over this. And like I told you guys in class, please don't worry about your grade. I'm going to count this as just like an assignment grade. All right, thank you.